Hey guys, sorry no video today. Something's wrong with the camera on this computer, but I'm sure that doesn't break your heart too much. I'm not too good to look at. But anyway, guys, I've got a little one sick again. It's kind of Murphy's Law is in effect. You know, everything can go wrong does. I was walking out this morning and he came running down and threw up. My wife only has 2 or 3 days left, so I'm at this semester if I ever have to stay home. So. That being said, we can't waste today because I'm wanting to be able to get to the lab to dissect later this week if we can swing it. So I need you guys to stay on task and do the things I was planning on covering with you today in class. Now, don't freak out. We will go back through this stuff again, make sure we're all on the same page. Because I plan on doing a little bit more direct instruction. It seemed like it worked well last unit. So today you're going to do a little bit of front work, do some research. That way when we go back over it together in class, it won't be completely new and introductory to you. It'll be more of a review for you because you've at least looked at these concepts and done some research. Speaking of that, here's what you guys need to do. Scroll down here where it says manipulating the body's adaptive capabilities. We're going to use a scenario to give us a reason to start learning about some of these other systems we haven't learned about yet. Alright, so first thing you need to do is you're going to click on this link right here. Oh, and we will be going into the cardiorespiratory system pretty soon. And I'll just continue to put part 1, part 2, and you'll see on this page right here, this is my main page where I keep the different units we're going to be going through and the introductory information. So click on this link. It'll take you right here, and here are driving questions. All right, here's what we're going to be using as a springboard to launch us into studying the body's systems and its abilities to adapt and be manipulated even through different variables. First one, what effect does a sudden increased demand or need for physical activity have on the body? Or how could one therapeutically mimic these demands and in turn the body's responses in order to elicit beneficial adaptations leading to improved health and longevity? That's kind of a long one there, so read it a couple times, make sure you digest and understand what it's saying. But like it says here, in an attempt to answer the driving questions above, we must first define what is a sudden increased demand for activity. It's pretty vague. Could be self-inflicted in an exercise or training or sport situation, or it could be a completely unforeseen situation where you're being chased by a bear or some sort of emergency. So I've got a couple videos here, all right, so you guys may enjoy them, all right. So the first thing, defining a sudden increased demand for activity. Well, if it's an emergency, click on this link here. It's a 4 to 5 minute or 3 to 4 minute compilation of various close calls and situations where you might have this need to go immediately, and your body's got to respond. Or it could be a self-inflicted increased demand for activity. And here's an example of anaerobic training. In other words, high intensity workout where you got to have energy and physical activity faster than what your body can get the oxygen to your mitochondria to stay on the aerobic pathway. So click on that, watch those 2 videos, and then down here the response that you were talking about, you're dealing with, is called fight or flight. I know you guys have probably heard that by now, but I want you to click on this video, and from it, see how many body systems you can identify that are involved or at work during the stress response. It may allude to it. You may have to make an inference. It may show a picture of it. Just ask yourself, so again, watch it carefully, listen, and make some inferences. What all systems, what all body structures are going to be involved in carrying out this fight or flight response? And then the next thing you're going to do is fueling the fight. All right, how your body supplies the ATP you need when oxygen can't get there fast enough. Because there are going to come times in your life when you're going to have ATP and energy necessary to fuel your body, but yet you don't have enough time to allow oxygen to get to the end of the electron transport chain to remove the electrons like normally. So again, click on this link right here. It'll take you to this page here. And I've got a graph here. You ACTers and college prep people, graph analysis is important. So check it out. It says the graph illustrates or represents the different stages of energy recruitment and generation during intense activity. Think sprinting all out as long as possible. Before you answer the following analysis questions, go to the link below, this one right here, and do some background research. You got to know what is the ATP PC system, what is the lactic acid system, aerobic system. This is the one we talked about in class with the case study. All right, these two have multiple names up to them. This link may give them different names. but you guys should be able to figure it out. ATP-PC, sometimes it's called ATP-CP. It stands for phosphocreatine or creatine phosphate. You'll read about it in this link below. Lactic acid system is sometimes called the glycolytic pathway, all right, or anaerobic glycolysis. Basically, it's just the glycolysis process, but instead of making pyruvate, it makes lactic acid because the NADH has nowhere to give its electrons because there's no oxygen available at the electron transport chain. So it just gives it back to the pyruvate, changes to lactic acid in order to free up the electron carriers and continue making our 2-ATP. But again, click on this link right here so you can kind of bone up, understand what the heck this is talking about, and then answer these 5 questions. Again, it's a skill practice for you guys that happens to be related to the topic we're learning about, fueling that ATP or fueling that fight or flight response. Once you've answered these questions, all right, answer them in your notes. All right, you're going to go back to this page right here. All right, and you can, if you want to, if you have time, click on this. But this is just talking about the cell communication that goes on during that fight or flight response. But this is where we need to get to: cardiorespiratory pacing and resources. You're going to click on this, and it's got day 1. That's today. All right, begin inquiry, introduction. All right, and you're going to, the first system we're going to take a look at is the cardiorespiratory system. So when you do this, you're going to click on this link. It'll take you to resources. All right, the link that's on my home page right here, cardiorespiratory pacing and resources. You click on that, it'll take you to the same page right here. All right, oops, excuse me, right here. All right, it'll take you to the pacing and day 1, day 2, things like that with the resources you're going to use. This right here is the handout you should get today in class. All right, it's just scaffolding. One of the things I got from the feedback was that, hey, if we're going to be doing research, make sure you give us some guidelines. What should we be researching? So this is it. This is my attempt to satisfy the masses and respond to the feedback accordingly. So again, you got to be doing some independent research. So, but this is going to be used to guide. These are the objectives. All right. So if you go to this link here and click on this one, it'll take you to the resources you're going to use. All right. So again, this is the handout they'll be given to you. I'm going to close that out. These are the resources, and it should be organized along with the handout. So again, here's another copy of that. This is a Prezi that a student created a few years back. That's pretty good introduction. But here's a blood link that's not on the organizer, but if you need a refresher on the different blood molecules, or not molecules, excuse me, blood cells that are involved, you can do that. But here's where you get to the meat of it. First part of it is going to be about blood vessels and circulation, heart anatomy and function. So click on these links. A lot of them will have, again, gets into the detail of it. All right, these should correspond with the research organizer as well. All right, so work through there. Don't worry about this part of it. All right, so let me show you. On the research guide that you guys have in class, I want you to get through the front page. All right. The nuts and bolts of the cardiovascular system is broken up into 2 systems. And then I want you guys to get through, let's see here. I want you guys to go ahead and just try to get the first page done. Don't worry about the second page. We'll pick up there next time. All right. So again, just going to get the first page done. That corresponds to these 2 links right here. All right, getting the nuts and bolts of the anatomy and function of the cardiovascular system. We'll start looking at heart rate and blood pressure and the effects of this intense activity on this system later on, because there's going to be an application part of it as well. All right. So again, that's what you guys are going to do today. You guys are going to answer those analysis questions. All right. First of all, watch the videos. All right. Introduce it. Watch the fight or flight video, pull out all the systems you can identify, click on this link. It'll take you to the fueling the fight, the different energy systems. Answer the 5 questions in your notes. We're going to be discussing those later on. Then go back to this page, click on part 1, or you can go to the home page. I've got it there as well. All right, click on part 1, or the cardiorespiratory pacing systems. You'll have this handout in front of you. Just do the first page. All right, using these resources right here. All right, blood vessels and circulation, heart anatomy and function. All right, that's where we need to get to today. We'll pick up the rest of this stuff later on and try to patch this thing together. All right, if you have time, I want you guys to go ahead and work through this, but in class, get through this. If you have time, work through this, because again, the more you can get through, the sooner we can get to the lab and start looking at these things, dissecting hearts and things like that. So guys, I hope you have a great day. I will catch back up with you on the flip side, and hopefully see you guys on Wednesday.
Hey guys, got a sick one this morning. Seems like everything could go wrong, but hey, Garrett, you got your wish. I'm not here today. So, but you guys need to do some work. Last time we started going back over the biomolecules to make sure everyone understood what those things were. If you didn't get that finished, make sure you get check with everyone in your group, or check with the other people in your group and find out what are those biomolecules, those macromolecules that are important. What do they do? Because today you're going to be clicking on this link right here. I even have it marked this one. So click on this right here, and it's going to take you to this page with a bunch of resources on it. All right. Now, this is our primary question. We started out with and the whole reason we started looking at the biomolecules in the first place. How's the cell membrane control what goes in and out of the cell? Once you get here, you should have a handout that's an information organizer, or like a piece of scaffolding support to help you stay focused on your research. And it should have sections that are marked similar to this with the same type of questions. These are the questions that all my classes came up with, or similar with it. What's the cell membrane made of? What do they do? What things move in and out of the cell? This is one that I added. It's not on your organizer, but I want you guys to check it out, see if you can figure out what moves in and out. What different ways things move in and out? That is on your organizer. That's one of the things you got that all classes ask. Well, how do they move in and out? Do they all move in and out the same way? So click on that. And then here's some different examples of how things move in and out. There's passive transport. All right, and I've got some links of different types of passive transport. So passive transport there's more than one type, and they all have something in common. One link that should take you there and hopefully work today. But again, there's different types: passive diffusion versus facilitated diffusion. Then you got this whole thing of osmosis, all right, and how they affect different plants and animal cells. Then you got this idea of active transport, and you ask yourself, why do they call it active transport? So as you're looking at stuff, so you can figure out what it is. Why do they call it active transport? But again, there should be a section on all the on the organizer for each one of these links to be used, all right, to learn and research. And when I get back in class, we're going to go back over these and make sure we're all, and I'll kind of give you some tweaks here and there and help you remember how some of the stuff works and ways to memorize, all right? Guys, I hope you have a great day. Stay on task. Do what's right. This is for learning. Don't be goofing off, because I need you to cover this stuff so when I come back, we can hit the ground running. Guys, I hope you have a great day. Be awesome.